This is parts of the atom and ion notation, and some things we need to know regardless of the symbols that they use. Here they've used A, B, C, and D. The location of the symbols and what they mean is what we're worried about. So A represents the element symbol. And identified by the atomic number, which is actually C down here. So C is the atomic number, which is the number of protons in the nucleus of the atom. B is identified as the ion charge, if there is one. And we determine that by canceling out the protons and electrons. And whatever we have left over gives us the charge of the ion that we're dealing with. Finally, D is the mass number, which is found by adding the number of protons and the number of neutrons. Remember that the majority of the mass of an atom is in its nucleus in the forms of protons and neutrons, and electrons circle the nucleus and weigh virtually nothing or have very little mass. So if we were tasked with coming up with this symbol for an element that had 9 protons, 10 neutrons, and 10 electrons, we would first go to our periodic table and figure out which element does in fact have 9 protons. If we do that on our periodic table here, we notice that that element is fluorine. Fluorine with its 9 protons sitting right here, atomic number 9. So we would put an F in the middle, and the atomic number goes down and to the left. So this has atomic number 9. So 9 goes there. Then the mass number, or the number of protons and neutrons together, would be 9 plus 10, or 19. And finally, for the ion charge, well, we have 9 protons and 10 electrons. So 9 of our electrons cancel out with 9 of our protons. We have 1 electron left over. That carries a negative charge. And so we're going to put 1 negative right here. Could also put -1. Conversely, if we're going the other direction, we have the symbol, and we're trying to determine the number of protons, neutrons, and electrons. Well, here we go. This element is magnesium. We don't need to go to the periodic table, but we could. Magnesium is right here. It's got its 12 protons, which is why the 12 is sitting on the bottom left. So 12 protons. To find the number of neutrons, well, we know that neutrons plus protons is equal to 25. So 25 minus 12, neutrons must be 13. Because 13 plus 12 gets us to 25. Finally, for electrons, we have a 2 plus overall charge, which means that this ion, has 2 more positive pieces in it, or 2 more protons, than it does electrons. So therefore, we're going to say this element has 10 electrons to cancel out 10 of the protons, leaving with 2 extra protons left over to contribute to our positive 2 charge. Finally, down here in what we call mass notation, if we have mass notation, we are not going to have a charge. This just identifies the number of protons and neutrons present, and therefore we can assume electrons from that. So we're just going to go protons, neutrons, and electrons. So for phosphorus, we look at phosphorus, and phosphorus has 15 protons. So this has 15 protons. This 31 or this number on the end, is the mass number. This is mass number notation. So we've got to go neutrons plus protons to get us to 31. So therefore we've got 16 neutrons. 16 plus 15 gets us to 31. In this type of notation, we assume there's no overall charge, there's no net charge. So they did ask us for number of electrons. We would say that they are equal. So we have 15 protons and 15 electrons. Over here for scandium-45, we have protons, neutrons, and electrons. If we go to our periodic table, scandium is actually element number 21 on our periodic table. It's right here, so it's got 21 protons. In this case, with this mass notation, we're also going to assume it has 21 electrons because it has no charge. And then finally, we go 45 minus 21. There's no harm in doing things like this because the number of neutrons plus protons are equal to the mass number. So this scandium-45 then must have 24 neutrons, 21 protons to get us to that mass number of 45. And from there you can work back and forth identifying charges on various ions. A couple of vocabulary terms that we also need to just show. A cation is an ion with a positive charge. So in our example earlier, the Mg2 plus cation. So this is an example of a cation or positively charged ion. And conversely, an anion is an ion that has somehow lost an electron, somehow gained an electron to become an ion with a negative charge. So up here, this F-1 or F1 minus is an anion. It's got one more electron than proton. That's pretty much what we need to know about parts of the atom and ion notation.